Hola, hi, this is Al, your statistics instructor. Let's get to work. In this video, we are going to be doing another example where we find a confidence interval for a proportion. Okay. So, the main idea of doing this example is, dealing with more complicated with a bigger data set. Okay, so we're going to be using R to find this confidence interval for a proportion. Okay, so the data set that I would like us to analyze is this. It has to do with ratings. Okay, so in this case we are interested in the proportion of viewers that watch a particular show during a particular time of the day. Okay, so the show that we are interested in is the Big Bang Theory. Okay, so this data set that we're going to be analyzing has information about 5 different shows, and well, code number 6 means that the TV is off. Okay, well, so as I said, we would like to estimate the proportion of viewers that watch the Big Bang Theory, and the code for that show happens to be number 2. Okay, so you will find that data set that we're going to be analyzing in my website. That's the URL. But what we're going to be doing here is we're going to go and find that file, and we're going to save it in a folder. So we're going to be reading that locally. Okay, so let me copy and paste that URL. So there it is, and then just go to File and save that file. Okay, the name of the file is rating, so it's a txt, it's a text file, so then just hit save and that's it. Okay, so I already have that one there saved in a folder that I created previously that is called sta258. Okay, so I got it. Okay, now let me launch R. We could launch R or RStudio. Let me launch R. It's the same thing. Okay, or well, let's use RStudio. So let me close this. Let me open an R script. You might need it, you never know. Okay, so first we would like to import that data set into R. We already have that saved locally in a folder that I created previously, right? That folder sta258, right? So first thing that I have to do is change my working directory. To do so, I'll go to Session and then Set Working Directory, choose Directory. So the one that I want, as I said before, is sta258. That's the one. Okay, now let's go back to our lecture notes and let me copy and paste that line, and I'll paste it here on that script, but then instead of the URL, right, I'm going to change that, and I'm going to have the option file, then open and close quotation marks, and then we need the name of that file. The name of that file is rating.txt. So rating.txt. Okay? Okay. So let's just, copy and paste that here. Now let's use the command ratings head, and then the name of our data set, ratings underscore data. That is going to show you the first 6 observations, right, of our data set. So we're good. Okay. Now, yeah, let me copy paste this. This is going to show you the names of the variables. Okay, but you have already seen them here. It's viewer number and the TV program, right? We know that there are 6 codes, and the one that we are interested in is number 2. That represents the Big Bang Theory. But again, if you wanted to see just the names of the variables, you could use that command, right? But we have already those. From using head, we have the names of the variables and the first 6 observations in our data set. Okay, so if you wanted to know, for instance, how many observations you have there, you could type this, dim as in dimension. Okay, so we have 5,000 observations. Okay, and we have these 2 columns. Okay, so this is basically what we did just a few seconds ago, right? Now, the first thing that we would like to do is to isolate the second column, right? The one that has the codes for the shows, right? So in order to isolate that information, that column, we could do this: the name of your data set, $, the name of the variable that you're interested in, and then we assign it to this variable called all.programs. Okay, let's copy paste. And then again, we could use head, and then we would see the first 6 observations of that object we just created, right? And it makes sense, right? It's the same as this. Here we have both variables. Here we only have one TV program, so it makes sense. Okay. Now, another way of doing that, since all programs is now a vector, you could do something like this. Use the index, right? Use the number of the element you want. So if you want the first 6 elements, that would work as well. Okay? See? Okay. Okay. Now, here comes something that could be useful. Okay? Remember that what we want to do is estimate the proportion of people who watch the Big Bang Theory, right? So we're interested only in the viewers who have as a value for the second variable the number 2. Okay, so one way of subsetting that is this. Let me show you what happens when we do this. Okay, when we do that, what we're asking R to do is this, right? So with these square brackets, we are telling R we want some of the elements of that vector, all programs, all shows, right? But then we add a condition here. We want those that satisfy that condition, that all programs is equal to 2. But note that we're not using just we're using the equal sign twice here. That is telling R that we want that variable to satisfy this condition, that all programs is equal to 2. We're not making an assignment like we're doing here, okay? See, all of them are 2's, okay? So then what we do is, oh yeah, those guys are going to be the Big Bang Theory, so we might as well name those elements, right? Those individuals that satisfy that condition as Big Bang, right? Those are the viewers who watch the Big Bang Theory. Okay, makes sense? Okay, so that Big Bang has the number of successes in our sample, because we're going to be considering a success if we observe a 2 and a failure otherwise, right? Okay, so now say that you wanted to see the first 10 elements. You could use those square brackets and type that 1 colon 10 is going to give you the first 10 elements of the object we just created, Big Bang. Okay? Okay, let's keep going. Now, we would like to compute that confidence interval for P, the proportion of people who watch the Big Bang Theory. Okay? So what we need is N, the sample size. Now, we already know that is 5,000. We have 5,000 observations, right? Another way of doing that, of finding that sample size, would be this. Let me create an object called sample size, and well, let me do it like this. Length of all programs, right? So it's 5,000. Okay, so we're going to assign that to a variable called sample size. Okay, now successes. We would like to count the number of 2's that we have here, and the number of 2's that we have in our sample is here. It's contained in Big Bang. So what we're going to be doing is creating an object called successes, and that guy is going to get the length, the number of elements in Big Bang. Okay, there we are. So let's see how many successes we have. 275, right? So our point estimate of the proportion P would be clearly successes divided by, you know, sample size. So 5.5%. That would be our point estimate. But we want something better than a point estimate, something more informative. We want a confidence interval, right? And if we're going to be doing this using R, it would be using a built-in function called prop.test, right? And here we have the syntax of that function. We need the number of successes in our sample, the sample size, right? and then the confidence level that we want. Okay, in this case the default is 95%. If you want a 95% confidence interval, you might as well just leave that blank, but okay. And then we have this option, correct equals true. What that thing is doing is applying a continuity correction. And since I want you to get the same thing that we would get using our formula when we do things by hand, I'm going to set that option equal to false. Okay, so here we go. Number of successes, x is this guy, successes. Then we need n, the sample size, and then confidence level. We know that the default is 95%, but just to be very specific, I'm going to type it. And finally, I will set that continuity correction equal to false. And there you are. So a 95% confidence interval is going to be from 4.9 to 6.16% roughly. Okay? And again, I'm setting that continuity correction equal to false. So if you did this by hand using our formula p hat plus minus c star times the square root of p hat times 1 minus p hat divided by n, you would get the exact same thing. Okay? So, just to summarize what we did today in this video is we learned how to use a built-in function in R to construct a confidence interval for the parameter proportion. Okay, and what we need to do to create that confidence interval is use that built-in function prop.test. The syntax of the function is, first we need the input that we need is the number of successes, your sample size, confidence level, and if you want to get the exact same thing that you would doing things by hand, set correct equals to false. That is just ignoring, is not doing a continuity correction. Okay, so again, that is going to allow you to get the same result that you would get doing things by hand using the formula that we have discussed before in our lecture notes. Okay, well, that's it for now. Thank you so much for watching. Please take care and keep working hard. See you next time. Bye.